we're going to kick off tool number 4, RealSensors. Just doing this or splitting the duties on this are going to be 3 of us. I'm Brian Gilligan. I'm the Deputy Director of the Office of Federal High Performance Green Buildings at GSA. I'll be presenting with Kevin Keene from Pacific Northwest National Lab. He's a building performance researcher, and Vivian Lofnitz from Carnegie Mellon University, Professor of Architecture. I'm going to give a high-level overview of what we're trying to achieve by incorporating sensors into workplace engagements. And then Kevin and Vivian will each share an approach we've used to put sensors in buildings and use the data to give us good workplace recommendations. Just to reiterate the list of tools that Liz has shared before, we're on tool number 4, RealSensors. I see this as an integral part of the first 4 tools. You really should use sensors in combination with other things, good team training, occupant survey, and facility scorecard all give you different perspectives that are very important. What sensors give you that's a little bit different is an understanding of actual conditions which may not be apparent to occupants. Before Liz said that people are good sensors of the indoor environment, Vivian has said similar things. I agree with that, but we're imperfect sensors. And we're imperfect for a couple of different reasons. One, we see the same conditions differently. Different people have different preferences and reactions. There are some things that we don't sense, and we're not in the same spaces all the time. So we have a kind of collective understanding of IEQ. Sensors are objective. You put one in a room, it'll measure continuously for as long as you leave it there and give you an objective view of what's going on. And so I think that really should feed into our kind of general philosophy behind sensing indoor environmental quality. In general, and I'm going to quote St. Thomas Aquinas in honor of my colleague and friend, Kevin Kelly, who used to say, "We see through a glass darkly." Our understanding of IQ is always going to be imperfect. Sensing gives you a view into what's going on in the space. And even though it's imperfect, it still brings valuable perspective to our decision-making and our understanding of the indoor environment. And the real power, I think, comes from combining sensor data with occupant surveys and expert observation, because it significantly enhances our understanding of and ability to improve IEQ. So just kind of keep that philosophy in the background. This is one part of many, shouldn't really be by itself. And our objectives are really to tailor IEQ improvements to the specific needs of each engagement site. And those 3 threads help us do that. We want to measure and record IEQ in a consistent manner because there's a lot of different ways you can approach this. And if we're consistent in doing this, we really should be able to compare IEQ outcomes before and after a project to see if we've made a difference, and across projects so we can get that kind of portfolio level understanding of how we can influence the indoor environment. And that's something that Vivian's going to talk about in relation to the work that she's done with the NEAT survey. We'll really show you some of the things we've been able to learn at a portfolio level. In doing sensing to achieve consistency, I think it's really important to adopt a consistent standard, and third-party consensus-based standards are really, I think, the way to go. We compared 3 of those standards in trying to understand what we were going to emphasize in our approach. RESET for commercial interiors, the WELL building standard for sensing, and ASHRAE's performance measurement protocol, which is in development now, or in updates in development now. These are all good because they tell you what to measure, how frequently to measure it, how long to measure it, and kind of what strategy you should use to deploy your sensors to get a good picture of what's going on. I don't want to go through each of these individually. I'll just say that we ended up emphasizing RESET for commercial interiors because we felt it was the right balance of rigor and flexibility in a project. And so what is our approach to sensing? What are you going to see us kind of going through today? Or what are you going to see in future workplace engagements? It starts with really a 2-hour project-specific training and planning session. This is what Liz mentioned we want to do at the beginning of the process, train the team. And this also gives us an opportunity to apply our requirements to the specific sites that we're going to be going to. We want to use a RESET accredited monitor. This is really to ensure that we get a kind of base level of quality for data accuracy and kind of the things that are being measured, et cetera. So RESET accredited monitor. We want the monitors to be placed according to RESET for commercial interiors requirements for distribution, or something that's roughly equivalent to that, again, to give us that consistent picture. And then we want a minimum 4-week short-term deployment. This is basically to make sure that we cover variations in operations or staffing or kind of events that happen, weather events, things like that. So that gives us a good picture of what's going on in the space. Today, we're going to talk about a couple of different ways that you can go about meeting these requirements. The first is the Healthy Buildings and Energy Support Toolkit. This is HBEST that was developed by Pacific Northwest National Laboratories. And the second is the National Environment Assessment Toolkit, or NEAT, which is done by Carnegie Mellon University. Each of these is a way that you can address most of the requirements in the specification that, or in the scope of work that we're going to be that I just went through. But you're also able to propose your own requirements or your own approach as long as it meets those minimum requirements. We're really just trying to give you an example of how you might go about doing it. I'll go ahead and go then to the next slide, which is introducing Kevin Keene from the Pacific Northwest National Laboratories, who'll talk through the HBEST tool. Kevin, I can advance. Just let me know when you want to go.
Sounds good. I see we also have a hand up. Do you want to have questions throughout, or what were you thinking, Brian?
Let's go ahead and hold our questions till the end of the session to make sure that we get through our material. So Robert, we will get you. If you want, you can put your question in the chat for now to make sure we don't miss it.
All right, so I'm going to talk more about the Healthy Buildings and Energy Support Tool, or HBEST. Just for context, we developed it with the Federal Energy Management Program, FEMP, and GSA about 4 years ago. It's an Excel tool, and we also have a version in GSA's D2D to help handle larger data sets from databases that Excel cannot handle. Hopefully that's enough sort of contextual information about it, because I'm going to kind of jump in the next few slides, but feel free to put any questions in the chat if I kind of missed some background information that makes this tool not make sense. So talking about the process, so the HBEST is a tool, but it also comes with an assessment process to get the data for the tool. So the process is to leave the IAQ monitors in place for 1 to 2 weeks. 1 to 2 weeks is what we said a couple years ago. We've kind of changed to 4 or 5 weeks to get more representative data. Since then, we found it's a little bit more optimal than the 1 to 2 weeks. But it's kind of under the concept that, the more is better, but at this point is sort of sufficient, I guess. So in addition to the IQ monitors, there's also survey questions. Liz went over the survey questions earlier that align with HBEST. And then we also have the total workplace scorecard questions that Michael went over, which we call the diagnostic information, which helps us identify customized improvement opportunities based on the data. So when to use HBEST, there's a variety of potential use cases. One is a pre-post retrofit comparison, so you can run the tool before and after a change and see how the results change. Another one is investigating specific IAQ problems and solutions, which may require a little additional analysis on top of HBEST, but it's a good sort of baseline for getting started for that objective. Benchmarking performance generally, so if you want to know how your building is performing in terms of indoor environmental quality, or compared to other buildings, it's a good tool for that. It can help you prioritize IQ categories. So HBEST separates air quality from thermal comfort from lighting. And if you want to know which one might have a better return on investment between the three, it can help you decide which one to target first. And finally, it can, the results can be used for justification for work orders. So if there's a work order for a specific retrofit that relates to IAQ, some of the information might be helpful for doing that. Next slide. So an important part of any IAQ assessment is benchmarking. You collect a lot of data, but you need to know what it means, what's good, what's bad. So for HBEST, we have this, divided it into acceptable conditions, which we call the conditions that reduce negative health impacts, and also the high performance targets. So these are the conditions that actively promote optimal health, comfort, and productivity on top of that. So these are the values that we use, and the references on the right side there for the different metrics that we look at. Yeah, that's all I have to say about that. Next slide. And then a little more about the outcomes from HBEST. So First outcome, like I said, it benchmarks IQ performance against these acceptable and high performance targets using graphs and tables. The second is estimating the potential financial gain from improving productivity from optimizing IQ conditions. So it basically says if you go from what you have from your measurements to what we defined as the high performance conditions, research generally says this is how much productivity improvement that you can see. And then it says, you know, if people are 1% more productive, then that means they can do 1% more work, which translates to, you know, 1% more of their value or of their cost to the employer. And so I think the main takeaway from that is not that, you know, this is financial value that you can, you know, see at the bottom line at the end of the year, but we like to sort of advertise it as here's a way of putting a number on health, a number that, you know, is easily interpretable and easily comparable between categories, just as a way of valuing health and the general magnitude of the savings, and not necessarily like the exact dollar value that you will save, because the translation from productivity to profit varies significantly from organization to organization. So, and then the last one is identifying applicable energy efficiency and health upgrades. So we have a collection of about 60 measures, and it will use the data to say, you know, maybe these 10 or 15 or whatever are applicable to this building, and it's a good starting point for identifying solutions. Next slide. And then I just put a few of the graphs here. We have a lot of graphs in the tool, but these are just two. The one on the left shows particulate matter being benchmarked. So it shows the daily averages for 3 different HVAC zones in those bar plots, and then it compares it to those horizontal lines, the yellow one being the high performance target and the blue one being the acceptable conditions. And then the one on the right, I mentioned we also use survey data. So this shows people's responses to survey data. I think it's just a hypothetical example, but you know, you can see that people's perception varies by season significantly, which is not uncommon, and they tend to be a little bit cooler in the autumn and winter than the spring and summer. Next slide. So we have a guide for HBEST. There's a link there at the bottom where you can see HBEST and the guide on FEMP's website. I'm going to talk a little bit about the guide in the next few slides and some of the main takeaways and considerations. So some of the stuff that it includes are, you know, how long to monitor, where to put the monitors, how many monitors you'll need. It talks about how to get the survey questions, how to set up a survey, how to look at the results, how to estimate the average cost of the employee, which is used for those financial values in the calculator, and also selecting the responses for the total workplace questions and putting it into the tool. Yeah, this image here shows one of the slides that has some information, but you can look at the link there for more information. Next slide. Just another thing I wanted to show, it also walks through how to put the monitors across a floor plan. So here's a hypothetical example of an office building with 2 floors and showing you how to select a representative sample of different space types and zones in the building. So that's also included, and I'll talk about that a little bit more. Next slide. All right, so I want to dive into the IAQ monitors. That's a big part of this sensing tool. So we tend to use the word monitor and sensor interchangeably. I would say technically the monitors are the entire device that may have 1 or more sensors within it that measures a specific metric. However, colloquially, they are used pretty often and interchangeably. So I try to use the word monitors because I'm talking about the entire device here, but at some point I also talk about the sensors. So this table has a couple of things that are relevant when you're thinking about what monitor to choose for an assessment or to choose for using HBEST. So you want to consider what metrics does it measure. And ideally, you want to have one monitor that measures a bunch of things so that you don't have to have a bunch of different monitors. You want to think about who's the intended user. Some are very clearly meant for researchers and are a lot more technical and often difficult to use. However, they tend to be more accurate and may have better data, whereas there's a lot of them that are for consumers and are intended to be easy to set up and use, but may have less flexibility around the data and the accuracy. But they're a lot easier to use, so it's good for, you want to think about who's going to be setting up and using these monitors and what level of complexity is ideal to make the assessment go smoothly. The next one is the cost. The cost of these sensors can range pretty significantly and may have implications to the accuracy and quality as well. Data storage and transfer. So a lot of the sensors that are meant for consumers are use Wi-Fi. They're often meant for people to use in their homes and connect to home Wi-Fi. However, Wi-Fi in federal buildings often has IT and other restrictions. So it's important to think about how the data is going to be transferred and stored. So think some of these monitors have local storage. They can be stored locally and retrieved manually, and that's always a good backup option to have. Another one is the hardware and software. Some of these require gateway devices for hardware or applications on a phone or tablet to set them up for software. So that may come with IT or other cost-related implications. And finally, the maintenance. A lot of these require maintenance or calibration or even replacement after even a couple of years. So important thing to consider when planning for building an inventory of these monitors. And then the last note I have there at the bottom, I'm mostly going to be talking about indoor monitors throughout this, but I just want to also note that it is really helpful in the studies that we've done to have an outdoor monitor. It's really good for figuring out the sources of indoor problems. So, if you see outdoor particulate matter that corresponds with indoor particulate matter, probably means the building's not filtering enough, or if it's really hot or cold outside, and it's the same in perimeter zones in the building, then maybe the envelope isn't doing a good job at insulating the building. So it does help dig into the data a little bit. The outdoor data isn't used in HBEST, but it is helpful to use supplementary data if doing a study. So I just wanted to mention that quickly. Next slide. All right, so the next few slides, I'm going to dive in a little bit more deeply about the monitors and some of the things I mentioned. So the first is
Kevin. Can I interrupt? Hi, this is Alison Ackerman. I work with Kevin on this, and he's doing a great job. I just wanted to, if you could flip back to one slide, I wanted to make two small comments before we go on, because I think what's really important here is Kevin mentioned the target audience of the monitors, and there is a huge range in the ease of using them. Some can be really tricky to set up, and some you just turn them on. And that's really important, because at the end of the day, if you can't get the data, it doesn't matter how fancy your monitor is. So I definitely give a lot of thought to that. And then he mentioned a bit about connectivity. It is really great in the studies that we've done when we've been able to get real-time data, so there's no lag, versus when people have to download the data and send it to us. This is a really big issue for federal buildings because they very rarely have public Wi-Fi that you can leave a device connected to. So it is important to think about how you're going to get the data. And in my opinion, those are probably the two most important factors when you're selecting the monitors. I don't want to overtalk. Kevin's doing a great job, but I just wanted to emphasize those 2 points as can really make or break the whole study. That was
Thank
all
you.
I had.
Okay, so did I finish the slide before that? No, I had a few more things. So yeah, talking about the metrics, Brian mentioned the reset standards. So the great part about the reset standard is that a bunch of monitors are coming out as reset accredited, which requires that they collect temperature, humidity, particulate matter, CO2, and TVOC. So that's been super helpful for us, finding monitors that can kind of be a one-stop shop for collecting a bunch of things, whereas before that we'd have to have 2 or 3 different monitors to collect everything. The one mentioned there is the Kytera sensor or monitor, which is reset accredited, among many others. In terms of connectivity, like we just said, Wi-Fi is great if it's available, but think about other ways like gateways, connecting to the BMS. That's an important part of how you get the data. Some monitors may require a mobile app to set up. So that's another thing to consider if you need to get like a phone or tablet to run that application. And then also a lot of these monitors require continuous power. So, having an availability to an outlet is also a limitation in some cases, in some spaces. And then for the data, we recommend at least a 10 to 15 minute sampling frequency. Most of these metrics don't vary too much within that time frame, but anything longer than that, 30 minutes, an hour, you start to lose a lot of granularity. And then just one small note at the end, the time zone is an important consideration. Make sure that the times are standardized between these monitors or even set to UTC if you're worried about daylight savings, so that you always know kind of what the data is and it's the same between all of them and you have a process for handling it. Next slide. Some notes on placement. So we recommend putting them in a place that is representative of occupants' experience. So you want to try to make sure that they're capturing what people are perceiving. So we say don't put them immediately next to windows, heaters, or vents that may have slightly different thermal or air quality conditions than the general space. And also putting them across the building in a set of representative locations. So if there's a lot of conference rooms that are used very regularly, then we want to put a representative amount of these monitors in conference rooms to capture that. We want to vary between core and perimeter because the conditions can change pretty significantly between those two spaces. Between orientation, northeast, southwest, also can be very affected by the sun and thermal conditions. And HVAC zones, different HVAC zones will have different performance. So we want to try to capture all of that as best possible. Next slide. A few other small notes. So troubleshooting, these monitors can get unplugged, moved. It's important to think about who's going to be in charge of checking on them. You don't want to go 4 weeks and then realize that you weren't getting the data that you wanted. So making sure that they're being regularly troubleshot is important. I mentioned before, the number of devices is a consideration. So the HBES guide recommends 8 to 10 locations per 50,000 square feet of building space. So you have to plan how many monitors are needed. However, one thing that we've done is if budget is a constraint more than time, you can measure half the locations and then change the monitors to new spaces for the second half to monitor more locations to have less of an inventory. And then finally, there's different seasons, and we know that the seasons can affect a lot of indoor environment and parameters pretty significantly. So ideally, we want to capture some data in heating, cooling, and shoulder season. I know that's definitely been challenging for us in the past. So if it's not possible, I think my main takeaway is just, consider when you're looking at the data that this is only a slice of what's going on in the entire building, and things may be different in other seasons. But if it can be repeated in other seasons, that is definitely recommended. Next slide. And then I just quickly want to mention some other, what I call supplementary assessments that we've done in the past with some of our studies. So these can be used in conjunction with HBEST and the IAQ analysis or not. Kind of depends on what the building and priorities are. So the first two are Energy Star Portfolio Manager and Building Energy Asset Score. It's been really helpful to look at the energy side of things, see how the building's doing for energy. Do we want to invest more in energy, or are we doing pretty good? And we can focus more on the IAQ side of things. So these screenshots, we have Portfolio Manager on the right and Asset Score on the left. Asset Score gives you a score from an energy model based on the model performance of the building, and also estimates the amount of potential savings that you could do through energy conservation measures to your building, whereas Portfolio Manager looks at the utility data and ranks you compared to similar buildings as a percentile. So that's the actual performance of the building. Another one is the lighting model. So we've done lighting simulations. We've also done lighting assessments with sensors. I didn't really dive into the lighting side of things. I focused on the air quality and thermal comfort because lighting is a lot trickier and I don't have time to dive into it too deeply. So I would say reach out to me if you are interested in lighting after, and I can give you more information. And the last part is trying to connect to other DOE programs. So a lot of the data that's collected as part of HBEST is a good kind of indicator of what the next steps might be. So DOE and FEMP, the Federal Energy Management Program, has a lot of other programs related to energy and sustainability, such as the retuning program, the integrated lighting campaign, O&M, water, energy reporting, distributed energy. And so some of these things, the HBEST assessment is really helpful for identifying if this is these programs could be a good solution, but they do have technical assistance available for federal facilities. So next slide. All right, to wrap it up, here's some resources that we have on the FEMP website. There's the links are live here, so if you can click on them if the slides are shared after, but send me an email. My email's at the bottom if you don't get the slides and you're interested in any of these. We have assessment guide, HBEST, HBEST training webinar, and interactive training platform. Next slide. And that's all.
Thanks so much, Kevin. Appreciate the run through there. Next up, we have Vivian Lofness from the Carnegie Mellon University Center of Building Performance and Diagnostics. And she's going to run us through the need assessment. Vivian, just real quick, how's your battery doing? And you're on mute, Vivian, sorry.
Yeah, I will turn off my camera to keep my battery alive. I'm in Germany, and for whatever reason, the amount of draw on my computer is greater than the amount of feed from the plug that I have. Maybe because there's an adapter in between my plug, who knows? But I should be fine as long as I don't run my video.
Sounds good. All right, take it away. I'll advance as you need.
Okay, so let's advance. Let me start by saying there is not a huge difference between what Kevin was just speaking about and what I'm talking about, except for two variables. One is we do not leave in situ monitors when we do an environmental assessment. We come in for 2 to 3 days and we measure, if we can, about 10% of the workstations. And we combine 3 different variables. One is the same metrics that Kevin was speaking about, but in a spot measurement. So it's not a continuous measurement for a week or 2 weeks or a month. It's literally a spot measurement. We use a user satisfaction survey, which is a right now survey. So we're asking people how they feel about the air quality and the thermal comfort at the moment at which we're measuring their air quality and thermal comfort and their visual quality. At the same time, the team, which is usually 3 to 4 people will be recording the physical attributes of the building systems. That's the mechanical system, the lighting system, the facade system, the furniture system, things that essentially should be influencing the indoor environmental quality and the user satisfaction. So we argue that all post-occupancy evaluation should include measurement and not just user satisfaction surveys. And it should also include the physical attributes of the building systems, because ultimately we're trying to learn what building systems impact indoor environmental quality and where should we in fact be improving things. Next slide, Brian. So in terms of the NEAT cart, which is the actual instrument cart, again, there are probably a dozen carts, instrument carts that have been developed around the world to actually measure visual quality, thermal quality, air quality, and acoustic quality. All of these carts predate the type of reset technologies that have appeared on the market in the last decade. So Kytera and AirThings and some of the other integrated sensor monitor systems are a relatively new phenomena. So what most of us who've looked at measuring indoor environments have had to do is to assemble lots of little pieces of sensors into some sort of a cart. And in order to really assess visual quality, you have to not only measure light levels on the desk, on the screen, on the keyboard, you have to measure brightness contrast, you have to look at uniform glare index. And today you would also be measuring circadian stimulus. So the amount of frequencies and variability of light, and specifically daylight, but not always daylight. So you can see here, there's a list of things that almost any sensor suite will try to capture when there is field measurements. We also record some personal factors because we've asked people about their thermal comfort. We've also recorded if they're wearing sweaters and jackets, and if it's okay, we record clothing and gender and age and activity rates. And we look for local signs of stress, people who've had heaters plugged in or fans on, they've got blankets at their workstation, whether they've got deodorizers running, taped over air diffusers, taped over windows. So we're trying to keep track of the type of signs of stress that would tell us, even if they're not telling us verbally, we can see that the visual environment gives them trouble. Next slide. For all of these measures, and again, almost any of the IEQ assessments, whether it's WELL or RESET or HBEST, they will always have a set of standards for which they're comparing the measurement against. And those are standards from ASHRAE, from ANSI, from EPA, from the International Lighting Illumination Engineering Society, from NIOSH, from OSHA. I mean, so the acoustic standards. So we're literally gathering the rules and then comparing the measures against those rules. Next slide. The key that we would argue good post-occupancy evaluation plus measurement is to always be comparing all three data streams. Now, the technical attributes of building systems could be your scorecard. It could be the other elements that we've been trying to collect over the last 2 decades, or actually 25 years. We've been working with GSA on field POE plus M, and we have a long list of attributes of building systems. You want to compare the attributes of building systems to the actual spot measurements, and you want to compare the attributes of building systems against user satisfaction, and you want to compare measurements against user satisfaction in order to draw conclusions. And so here is the whole suite of the data set that becomes the basis of evaluation. Next slide. As Kevin mentioned, sampling is a challenge. You can't measure every workstation. You can't put hundreds of environmental monitors. You're going to have to decide what is prototypical. You have to do some in the core of the building and some in the perimeter of the building. You need to do some monitoring in closed work environments and some in open plan work environments. And more recently, we need to measure assigned and unassigned workstations. Now, this is actually a sampling diagram for the 3 floors of Interface's headquarters in Atlanta called Base Camp. And you can see here where we measured. Now, sometimes we have a series of dots on a floor plan, and when we walk up to that workstation, there's no one there to survey, so we don't test that. Or we walk up to a workstation and someone says, I don't have time for this. I will not fill out your survey and you cannot displace me to measure my environment. And so our dots have to be, by very nature, more flexible. But anyway, here's a sampling diagram for environmental monitoring. Next slide. I have to say, Interface Base Camp was the first non-territorial agile workplace that we have done POE plus M on. And it's designed specifically for a combination of collaboration and concentration. It was designed before COVID, but it has certainly served them well through COVID. And being non-territorial completely changed the results of our findings. Next slide. On the left is user satisfaction, and these are 7-point scales where there's 3 positive and 3 negative and 1 neutral, where you basically say, are you happy with the lighting? Are you happy with the task light? Are you happy with the ambient light? Are you happy with glare management? And you can see in the interface, people were really happy. On the thermal IAQ, they were very happy with the indoor air quality and not very happy with the temperature. However, they were much happier than they were in 30 other US buildings, of which about 23 of those are federal buildings. So thermal discomfort is very red, and that's that first bar in the thermal suite. In interface was problematic, but in the federal in larger set of US buildings, it's even more problematic. The same is true with acoustic and visual privacy. Clearly, in an open plan workstation, people do not feel like they have a private place to work, nor do they feel that their conversation are private or secure and or not bothering other people. And so there's a lot of complaints about privacy in today's work environment. But in the interface case, the complaints were measurable, but much less measurable than they were in the other buildings that we've studied. And this is just a user satisfaction. I'll show you some of the measured data in a minute. Anyway, this is one way to display a 7-point scale, of which there are 3 positive points and 3 negative points and 1 neutral point. And it was pretty revealing to us that this new work environment at Interface was pretty brilliant in terms of what it's accomplished. Next slide. An example of spot measurements. So you go in, you measure workstations, you can pick up CO2 levels. The mean CO2 was at 717 parts per million. The relative humidity was surprisingly low at 35%. We were there in March, and it has a dedicated outside air system with active chilled beam, and it kept relatively dry air. You can see it's well within the standards. The green is where the standards would want it to be. The noise criteria was higher than the standards would want it to be, but it is what you see in open plan all over the country. Next slide. The technical attributes of building systems, we have a 2-page checklist of things that we look at, and we actually have a 7-point scale on them where we basically look at the ceiling fixture type. We do know that indirect direct fixtures have a much higher satisfaction, so we put them on the far right of our checklist. And recessed troughers with flush lenses have a very low satisfaction, so we put them on the left side of our checklist. And we just literally circle what's in there around your workstation. And everything that's red is a problem. They had flush prismatic lenses on their light fixtures, which was a problem. They were their own glare source. Everything that's green was good. They had 100% seated view. Every workstation had a view to the outside. It was quite beautiful. Every work environment had a task light. It had an articulated arm so you could reposition it. And every workstation had an independent screen that was adjustable, sometimes a dual screen. So they'd done a lot of things that were really very positive, and then there were a lot of things that were just very neutral. Next slide. The thermal and air quality ones, you can see there's a little more concern, a little more good and bad. They had a separate thermal and ventilation system. They had active chill beams with constant volume ventilation. Those were really, really good additions. But they had no dedicated perimeter heating or cooling. That turned out to be a bit of an issue. They had no visible thermostats. Nobody knew how to control anything. The diffusers were well aligned with the workstations, which is great. They had dedicated outside air with dehumidification, which turned out to be very good. Return air density was relatively low. So you can see here, and we did see sweaters. People were too cold. There were too cold complaints. There were some people who were too hot in glassy areas. So you can see here that we can, in the technical attributes, capture some things that will inform us for the future. Next slide. In closing on this particular building, air quality satisfaction is very high. We think dedicated outside air is pretty brilliant. An independent thermal conditioning, in this case with an active chill beam in Atlanta. By the way, ASHRAE's headquarters in Atlanta also has active chill beams. So even the mechanical world is beginning to realize you can use water-based thermal conditioning and provide for much more local thermal conditions. Visual satisfaction is very high. A lot of that is due to the daylight and views. Acoustic satisfaction is substantially higher than what we're used to seeing, but not fabulous. The real advantage acoustically is that they have completely closed and acoustically tight meeting rooms and focus rooms. So the pictures on the left show you a relatively large meeting room at the top right, a small meeting room at the bottom right, and then the focus rooms, which can sit 2 people or 1 person on the phone, in the middle on the left. And you can just choose where you need to be. If you want to meet with 1 other person or 2 other people, you take a small meeting room or go to the large meeting room, and some of them you have to sign up for. But this made a huge difference because people took their conversations out of the open plan. So it really made a difference in why we saw much higher acoustic satisfaction. We did see 2 major problems, which we recommended they fixed. One is that right now the space temperature is at 72. People were already dressed for summer, even though it was March, late March, and they were freezing. And they really need to raise their set points to 74. We also found that the focus rooms and the small conference rooms, which are acoustically tight, which means they're also airtight, only turn on the air if you turn on the light. But people didn't turn on the light because there's plenty of daylight. Or if you're in a focus room, you didn't really want to be in a little showcase. You wanted to sit in that very, very quiet light level and talk on the phone or work on your computer. So people weren't turning on the light. Consequently, the ventilation, the provision of ventilation in those rooms wasn't turning on. So we said, you have to disconnect this from the light fixture and put an occupancy sensor to turn on that air. Next slide. Just to keep in mind, if you get to Atlanta, go visit Interface. You can also look at all of their biomimetic carpeting. It's a pretty fabulous place. It's not completely unassigned. They do have a small number of assigned workstations. Certain workers need to be there every day, but almost everyone comes in and picks the place they want to work. For every couple of hours, they may rotate. They've got a fabulous rooftop terrace work environment. They've got some big training centers, and they will host you. So it's a pretty amazing. It also was written up in a WELL blog because it is a WELL certified work environment. Next slide. I'm going to take a few minutes to talk about what we're finding across multiple buildings. Because GSA has funded Carnegie Mellon and collaborated with Carnegie Mellon over 20-some plus years on doing post-occupancy evaluation with measurement, we actually have a lot of measurements. In fact, we have about 2,000 workstations across 75 buildings, or 2,500 workstations, plus user responses right now, surveys in those workstations, and the technical attributes of the building systems around them. And when we start to pull all that data into a data set, we find that user satisfaction with air quality is highest when CO2 is lower, when there are operable windows, when the quality of the window is higher and not leaky, when there are dedicated exhausts for the copy room, when the partitions are a little bit lower, and when the return air density is a little bit higher. So we can start to see guidelines for the future of our workspace design. Next slide. This is just giving you an example of all the CO2 measurements across, and you might recognize some of the buildings across the bottom because a lot of them are federal buildings, but not all. We have Amgen. We've got 4 buildings on the Amgen campus in Northern California. We've got Electricité de France in Paris, but a lot of these are, we've got a United Technology building study. If you do the next slide, Brian, it'll show you. This is what ASHRAE, there is no EPA standard for indoor air. But there is sort of a recommended rule of thumb that you shouldn't be over 1,000 parts per million. And as you can see here, almost all the workstations we measured were under 1,000 parts per million, except for 1, 2, 3, 4, 5, 6, 7, 8 buildings. 8 or 9 buildings, right? There are a number of buildings and only some of their workstations had higher parts per million. Next slide. But you'll notice all those red and green dots. And do one more slide. I'm sorry, I shouldn't stage these, but all those red and green dots are satisfaction with indoor air. And if it's red, they're not satisfied. And if they're green, people are very sad. Darkest green, very satisfied. Darkest red, very dissatisfied. If you want to ask occupants what should be the threshold, it's pretty clear it should be about 600 parts per million. If you want to get rid of the red dots and you want satisfaction, you're going to want to set it as 600 parts per million. Next slide. We actually did a statistical analysis and found that across the 7-point user satisfaction survey, that the sweet spot is at about 600 parts per million, or a little bit higher, 605 parts per million. Anything above that, you're going to start seeing a little bit of dissatisfaction or a lot of dissatisfaction. Anything below that, you're going to see more and more satisfaction. So data will give us some real insights on what, now this is just satisfaction. As Brian said, humans are not really good sensors for CO2, other than, do we feel a little sleepy? Do we feel the space is a little stuffy? But the question is, do we value the need for people to feel satisfied with the air quality? And I think the answer is we do. We want that to happen. And so CO2 is one of the measures that we want to get right. Next slide. This is now comparing tabs to data or to user satisfaction. And what we started to measure was the size of the mechanical zone. The way in which we record this is we count the number of thermostats on the floor and the number of people who are served by those thermostats. Now, it's getting harder and harder to find the thermostats because they're hidden. But up until recently, you could literally walk around and count the thermostats on the wall, and you knew the size of every mechanical zone for thermal comfort. These are not mechanical zones for air quality, even though they're supposed to deliver air quality. They're literally, the thermostat is just to make sure that the zone that you're sitting in is within the band of temperature that the system is designed for. And what you'll see here is that most buildings have between 5 and 15 people sharing a thermostat across 64 of the buildings in our data set. Next slide. The not so surprising thing was that the smaller the zone, the higher the satisfaction with thermal comfort. And in fact, the only way you can get 80% satisfaction with thermal comfort, which is baked into the ASHRAE standard, is to have individual thermal zones. You can't get 80, you can get 60% if you have 5 people sharing a thermal zone. But if you seriously want to meet code, you should be having a zone for every workstation, which would be a great goal to have for the future. Next slide. We were interested to see if operable windows made a difference in user perception of air quality. 76% of the workstations we studied had fixed sash windows. 24% had operable. Next slide. GSA still has some operable windows in their portfolio. It turns out that satisfaction with air quality and satisfaction with air movement is statistically higher if there are operable windows than if they're not. Again, this is satisfaction. This is not necessarily a full suite measure of indoor air quality, but anyway, the data is showing that if we want to have higher satisfaction with air quality, we need to start thinking about operable windows and finding the right mechanical systems to support that. Next. Partition height was an interesting one. We looked at partition height for lighting quality. We looked at partition height for acoustic quality. In this case, I'm just going to talk about the air quality. This is based on 500 workstations in open plan, so we're not looking at the closed offices. In this case, we've got 270 of those workstations which were low or medium height partition and 230 that were high partition. Next slide. Maybe no surprise, low partitions result in better user satisfaction with overall air quality and with air movement. And that's because the partitions frustrate the distribution of air, which also may frustrate our ability to keep bacterial and viral, buildup and TVOC buildup, and right. So truthfully, partition height is a critical factor in improving indoor air quality and indoor air movement. Next slide. I'm not going to do any more details. I'm happy to answer questions. I just wanted to give you a sense of when we did a portfolio statistic analysis with everything we could throw in across all the workstations we've studied. There were 4 things that determined acoustic satisfaction. One was the size of the workstation. No surprise, I'm sure, to anyone on this call, the larger the workstation, the greater the satisfaction with air quality. The second is the suppression of distributed noise sources. Those include copiers and printers and kitchens and things that if you throw them in the middle of the work environment, you're going to have less acoustic satisfaction. A third one is the number of partition sides that you have. If you have partitions on 1 side, 2 sides, 3 sides, or 4 sides with sort of a portal, you have higher satisfaction. And partition height, in this case, a higher partition results in higher acoustic satisfaction. Next. In lighting quality, there are some obvious things. One is the level of illuminance on the horizontal surface, assuming that people are still doing any paper-based tasks. Another is the luminance ratio or the brightness contrast, especially in areas where you have a distance view of a window or you have an overly bright light fixture. The type of the ceiling light fixture, the type of the lens on the ceiling light fixture, the type of the shading. I particularly am a big proponent of horizontal Venetian blinds, which can be put into a down and open position in contrast to a mesh shade, which can only be put into a down position and completely frustrates the quality of view of our biophilic landscape. And of course, access to seated view has an impact on satisfaction with lighting quality. Anyway, those are just some cross-sectional analysis. We do actually have a PhD thesis on this that can share you all the analysis results and a number of journal articles. Next slide. I think that's it for me, Brian. Yeah.
Great. Well, thanks so much, Vivian. As usual, a tour de force analysis, taking some very complex subjects and data sources, data streams, weaving them together in a really integrated way. Appreciate your going through that. We do have some time here for questions. I did want to just say one kind of concluding remark. I mentioned at the beginning that we're going to be integrating requirements for sensors into national engagements, and we're using reset for commercial interiors as the basis for kind of the minimum standards that we want to enforce. I also mentioned that we will accept acceptable equivalents, or alternate approaches that you might take in your projects. And we just went through 2 of them that I think meet the bill. The HBEST tool that Kevin mentioned kind of meets the duration of measurement and weaves in the 2 specific tools that Liz went over for surveys and Michael went over for scorecards into one package. So that's acceptable to us. The other is the NEAT project or process that Vivian just went through. That's a different approach. It's a moment in time, but they link 3 different data streams at that time. So you're getting people's immediate reaction to the environment that you're measuring and an observation of the conditions by experts in that space at that time. And as Vivian says, you can use the scorecard to give you that expert observation too. So those are acceptable equivalents. You can adopt HBEST yourself, or you can bring PNL or CMU into your project. There are ways that we can kind of contract for that consulting expertise. But in any case, what you need to do is make sure that you're combining sensors, surveys, and scorecard together to give you those three perspectives on the indoor environment. That's going to give you the best perspective on what you need to do to improve that environment with your project. And with that, we have about 4 minutes for questions. If anybody has any, please feel free to come off mute and ask, or throw your question in the chat. Either way will work.
No
Well,
questions.
I think the tour de force can be a little bit overwhelming, I will say. A lot of information that we went through there. I guess, Vivian, I'd ask you your perspective on kind of the what you think of the difference in the kind of spot measurements versus the continual measurements that we take. Is more data inherently better? And can your process be used multiple times during a year to give you a kind of more consistent picture of a given space?
Yeah, and actually, Brian, I know you shared the interface report, but you should have the Chicago report too. We have done before and after studies. They were spot measurements. We did it for the Chicago Federal Building. It's a good number of years ago, but it gives you a sense of how effective that renovation was, both at user perception and IEQ, and of course the technical attributes of the systems got better. So number one, you can use spot measurements in a before and after. You could do multi-season. There's no question that more data is better. We are not picking up thermal anomalies. We're not actually asking people to fill out a long-term satisfaction questionnaire. I do think that the CBE questionnaire is an invaluable asset to understanding whether different seasons people feel really hot in the summer or really cold in the summer and really hot in the winter. So I do think that long-term questionnaires and more in situ monitoring has an incredibly positive role to play, especially as we start to pursue the IAQ challenges that are causing health concerns. These spot measurements are not going to tell us if we have, higher incidences of colds and flus and what might be contributing to that. It's taken more recent measurements, long-term measurements, to tell us that particulate matter is critical to COVID infections. I mean, who knew? Because it doesn't seem like particulates has any relationship to COVID, but it turns out that we don't transfer our COVID infection through surface contact or even through handshakes. We exchange it by essentially breathing, and particulates carry it across the workspace to our neighbors. And the more particulates in the space, the higher the infection rate. I mean, it's not hugely higher. These are 1%, 2%, 3% increases, but particulates turns out to be a critical phenomenon. We would never have known that from spot measurements. So there's a place for both of them. Yeah.
Great, thank you so much, appreciate that. If you do have questions, folks, please feel free to reach out to the email addresses that are listed there. We'll be happy to answer any questions you have. And with that, Liz, we'll turn it back over